Hey kids, Mr. Martin with the video for this loops practice that we covered. So for number one, it says, consider the following method definition. The method print all characters is intended to print out every character in str, starting with the character at index 0. So all this is going to do is try to print from the start until the end. And as it's currently constructed, it will do that. If we look at the string that it gives us, print all characters, this is indexed as 0, 1, 2, 3, 4, 5, 6. And the length of the string is 7. So length is equal to 7. So the question is, which choice best describes the difference, if any, in the behavior of this statement that will result from changing less than to less than or equal to in line 3? So line 3 is right here, they reference it for us. So we're basically saying what happens if you change this from less than to less than or equal to, and we'll just take this out and put 7 so we have a concrete example. Well, if we change it from less than to less than or equal to 7, A can't be correct because by adding equality, it's not going to run less. It may run more, and it may run the same number of times. But if we're going up by 1, it's going to run more times because it's going to consider the fact that X could also equal 7. So A is not correct. B, the method will print more characters than it did before because the change because the loop will iterate more times. That would be true if we weren't printing characters from a string, because at some point we're going to run out of stuff to print, so it won't actually work, which is why C is the correct answer. So this loop would work just like the one with just less than would work until we get to X equals 7. So when we get to X equals 6, 6 is less than the length of the string, so it's going to do string.substring 6 to 7, which we know would print the 6th character and go to the end. The 6th character would be G, so when X equals 6, this works. But because 7 is less than or equal to 7, the next time this loop executes, it's going to look for substring 7, 8. And since strings are 0 indexed, the last character has an index of 6, not 7. So C is the most correct answer, because at index 7, it's going to just cause an out of bounds error because it doesn't have anything to access. So C would be the correct answer. For number 2, we have 2 different code segments. We have one segment that says int sum equals 0, for int k equals 1 up to and including 30, increment by 1, sum plus equals k. So this first thing, what does it do? It sums the numbers from 1 to 30, and we're going to put inclusive, because it includes 30. So it's just 1 plus 2 plus 3 plus 4, all the way up to 30. The second code is int sum equals 0. You start out at 1. You go until k is less than or equal to 30, but you add 2 every time you increment k. So this is going to be 1 plus 3 plus 5 plus all the way up until you get to 30 plus 29, and then it would try 31, but 31 is not less than or equal to 30, so it actually won't consider that. So this second code segment adds the odd numbers from 1 to 30. So the question is, code segment 1 prints the sum of the integers from 1 to 30 inclusive. Which of the following best explains how the output changes from code segment 1 to code segment 2? So A is clearly not correct, because we know that they don't output the same number of values. Code segment 2 will print the sum of only the even integers from 1 to 30. That's not true, because k starts at 1. And they're trying to trick you with the k plus 2, because if we're skipping numbers, if we generally start at 0, it would make you think that we do 0 plus 2 plus 4 and so forth. Option C, code segment 2 will print the sum of only the odd integers from 1 to 30 inclusive because it starts at 1, increments k by 2s, and terminates when k exceeds 30. So again, C is going to be the correct answer because the code runs from 1 to 30 and stops when k exceeds 30, but we increment by 2 every time. E is not correct because we just don't go to 60. We're not, if K went to 60, that would be correct, but that's not, and D is not correct because it's only odd numbers, not even numbers. For option 3, or for number 3, we have this loop that says for int, so K starts at 0 and is less than 20, and we go up by 2 every time. So then inside this loop, if our iteration value divided by 3 is equal to 1, print K plus a space. So we're increasing by 2, and we only consider the numbers that give a remainder of 1. So the numbers that are divisible by 3 with a remainder of 1, so let's see, like first when we started with K, we're gonna have K first would equal 0, then K would equal 2, K would equal 4, 6, 8, 10, 12. We can't see this. So 12, 14, 16, 18, and so 20 is not less than 20, so we won't include that. So 0 divided by 3 does not give a remainder of 1. 0 divided by 2 does not give a remainder of 1. 2 divided by 3 does not give a remainder of 1. 4 divided by 3 does give a remainder of 1, so 4 will print. 6 divided by 3, not a remainder of 1. 8 divided by 3, also not a remainder of 1. 10 divided by 3 does have a remainder of 1. 12 won't work, 14 won't work, 16 will work, 18 won't work. So the output that we're looking for is 4, 10, and 16, which is going to make B the correct answer. For number 4, we have, all right, so K equals 1 up to 100, and we increment by 1. And if K divided by 4 has a remainder of 0, print K. So if we just wrote what this would give us, 1, 2, and 3 don't have a remainder of 0, so we would have, basically this is saying print the multiples of 4. So this is going to be 4, 8, 12, 16, 20, blah, 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 96, and then 100. So we're looking for the code segment that will give us the exact same thing. So for number 4, we can just look and see what each one of these prints. So for A, this is saying start at 1, go to 25, increment by 1, and print the value of K. So it's going to be 1, 2, 3, 4, 5, 6, and so forth. A is not correct. For B, it's saying start with K equals 1, go up to 100, and then increment each value by 4. So we're going to have 1, 5, 9, 13, 17, 21, so forth. B can't be correct. For C, K equals 1, go up to 100, increment by 1, do K mod 4. So 1 mod 4 is 1, 2 mod 4 is 2, 3 mod 4 is 3, 4 mod 4 is 0, 5 mod 4 is 1, 6 mod 4 is 2, 7 mod 4 is 3, 8 mod 4 is 0. It's just going to give us values 1, 2, 3, 0, 1, 2, 3, 0 over and over again. C cannot be correct. For D, int K equals 4, K is less than or equal to 25, K equals 4 times K. So for K equals 4, it's going to do 4, we multiply by 4, and so the next value is going to be 16, and then we multiply by 4 again, so that's going to be 64. We multiply by, well, actually, until K is less than 25, so we only get to 64, and 64 is not less than 25, so this only gives us 4 and 16, so D is not correct. So just by process of elimination, we get to E, and let's see why E is actually correct. So int K equals 4, K is less than or equal to 100, K equals K plus 4. So that means that we start at 4, go until k is less than or equal to 100, but increment the value by 4 every time. So we're going to have 4 and print k. So we're going to have 4, add 4 to k. That's going to give us 8, print 8. Add 4 to 8, which is 12, print 12. And keep doing this until you get to, let's see, we have k equals 96. 96 is less than or equal to 100. Add 4 to 96, you get 100. Print k, so we print 100. 100 is less than or equal to 100. So we do k plus 4, print 100. So then we'll get 104. So E is the correct answer. For number 5, they give us this condition that num has to be greater than 0. And it says, let's see, public static int. So it's a method that returns an integer, do what to some number. So the int var is equal to 0. For the loop is less than 1. The loop starts at 1. It runs until we get to num, and we increment by 2. So we go from 1 to 3 to 5 and so forth. So var plus equals loop. What is the best, which best describes what this method does? So imagine we print, let's set num equal to some value that's greater than 0. We would have num maybe equals, let's choose 8. So now we know that this needs to be less than 8, and loop again starts at 1 and goes up by 2. So var starts at 0 and we add 1 to it. Plus equals loop means that we take the value that's in var, add loop to it, and store that back in var. So initially we're going to have 1, we add 2 to that, and so now loop has a value of 3. 3 is still less than or equal to 8. So then we plus equals what's in var with loop. So that's going to be 1 plus 3 now, which is 4. So now var has the value of 4, and we added 3. We add 2 more to loop, and so now loop is 5, and 5 is still less than 8, so we add 5. And so now var has a value of 8, and then we add 2, so we get 7, and 7 still less than or equal to 8. So we do plus 7 again, and now this has a value of 15, and we add 2, and so now we get to 9. 9 is not less than or equal to 8, so we stop. It seems as if this loop just adds the odd numbers from 1 to whatever num is. Let's see. So the options are the sum of all of the odd integers between 1 and num inclusive. Now, the inclusive part, let's see. It says less than or equal to. That's going to mean inclusive because num could have been an odd number. So the answer that we want is D. For number 6, which of the following represents the value returned as a result of the call compute in K? So let's start out with something. We want to say answer equals 1 and n is K. So let's say we start out with 3 and 4. So we have n answer equals 1. For n I equals 1, I is less than or equal to k. So in this case, I is less than or equal to 4. We're going to go up by 1, and we just want to do answer times equals n. So in this case, 3. So the times equal means that we take whatever is in answer, multiply by 3, store that back in answer. So when I is equal to 1, we're going to have 1 equal, so answer is equal to 1 times 3. We're going to use just A for answer. So that's 1 times 3 the first time. So A equals 3. Then we add 1 to I. And so then we're going to do, well, now we're going to multiply by 3 again. So we're going to have, let's start this over. So for A1, we get 3. For when I is equal to 2, we're going to have, 3 times the previous value, which is 9. We add 1 to I, we get a 3. 3 is less than or equal to 4. So then we're going to multiply by 3 again. We get 27. We add 1, we get a 4. Multiply by 3 again, we get 81. And so then we add one more. 5 is not less than or equal to 4, so we stop. It seems like the thing that returns here is n to whatever power of k that we have. And so that's going to make C the correct answer. Number 7, consider the following 2 code segments. Code segment 2 is a revision of code segment 1 in which the loop header has been changed. So let's see what each one of these does. K starts at 1, K is less than or equal to 5, K increments by 1, we print K. So we expect this to print 1, 2, 3, 4, 5, and stop. When K is 6, 6 is not less than or equal to 5, so this won't trigger anymore. For 2, K starts at 5, runs until it's less than 1, and we subtract 1 from K each time. So this is going to print 5, 4, 3, 2, 1. So if we go through our answer choices, let's see, both code segments produce the same output because they iterate 4 times. That's actually not true. They iterate 5 times, so just that makes it incorrect. B, both code segments produce the same output because they both iterate 5 times. That's not true because the first printed value for the first segment is 1. The first printed value for the second segment is 5. C, code segment 1 prints more values than code segment 2 because it iterates for 1 additional value of K. That is not true. They both print 5 times. Code segment 2 prints more values than code segment 1 because it iterates for 1 additional value of K. That's also not true. And then the code segments print the same values but in a different order because code segment 1 iterates from 1 to 5 and code segment 2 iterates from 5 to 1. That is the correct answer. My recommendation for all of these questions where we have multiple code segments is just analyze what the loop does, right? Actually write down the values and understand what the loop is executing. For number 8, which of the following code segments will produce the same output as the code segment above? So we have, let's see, K starts at 1, goes until K is equal to 7, because 7 also works. And then we, this plus equals means that we just increment K by 2. So we're gonna have 1, for K we're gonna have values 1, 3, 5, 7, and again, we go until K is less than or equal to 7. 7 is less than or equal to 7. So 9 won't trigger. So we expect this to print 1, 3, 5, 7 because it just prints the odd numbers. Let's see. So K starts at 0 and increments by 2, which means that we're going to print 0, 2, 4, 6. A can't work. B, K starts at 0, less than or equal to 7, plus equals 2. We're going to have 0, 2, 4, 6. B also doesn't work. It's basically A, but K could equal 7, but it won't because we're only printing even numbers. C, K equals 0. So K starts at 0, goes until K equals 8, and we add 2 to each value, print K plus 1. So let's examine this one. If K is 0, 0 is less than or equal to 8, print 0 plus 1, so we're going to get 1. Then we're going to add 2 to that, so K is going to be 2. That's still less than or equal to 8, so 2 plus 1 is 3. Add 2 to the value of K. Remember, K is an even number, so K now is going to be 4. 4 plus 1, 5. Add 2 to K, so K is 6. 6 plus 1, 7. Add 2 to K, 8. 8 is less than or equal to 8. 8 plus 1 is 9. We need a code segment that prints just 1, 3, 5, and 7. Just 1, 3, 5, and 7. So C actually doesn't work, even though it kind of looks like it does. For D, K equals 1, K is less than 7, increment by 2. So now, again, K is going to assume the values 1, 3, 5, and 7. Well, 7 can't be included. So if K is 1, we're going to have 2, 4, and 6. D doesn't work. So again, by process of elimination, we get to E, where K starts at 1 and we increment by 2. So that means that K is going to be 1, then 3, then 5, then 7, and 9 not less than or equal to 8, so we stop, and then we just print the value of k. So since k is these values and we print k, E is going to be correct. The last one that we're going to do is 9. Number 10 is a while loop question, which we'll address at a later date, which is just next class, honestly. Which of the following code segments will produce the same code segment as the one above? So let's see. Count starts at 0, k equals 0, goes until k is less than 10, increment by 1. So k is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it's just going to add 1 to count. So just, this means add 1 to count and replace. So and replace count with the new value. So let's see. This is going to run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. And so we expect count to be 10 when we print. Which one of the following code segments will produce the same output as the one above? Whichever one gives us 10. Let's see which one that is. So for number so we need something that's going to run 10. We need a loop that's going to run 10 times. This is k is going to be 1 through 9. So A won't work. For B, count is k is going to equal 1 and go up until and include 10. So we're going to have 1 through 10 inclusive and just add 1 to the value of count. So B is going to be the one that works. Let's examine why. Oh, no. I'm sorry. Oh, B is not correct because count starts at 1. So this is actually going to give us a value of 11 at the end. Count starts at 1. So for option C, count starts at 1 and it runs 0. So it's going to run 0 through 9 inclusive. So that means it's going to run 10 times, but count is already 1. So when we add count 10 times plus the one that already exists, this is also going to give us 11. So C can't be correct. For option D, we have count starts at 0, starts at 9, goes down to 0 inclusive, subtract 1 each time, and increment count by 1. So this is going to go from 9 to 0 inclusive, which means it executes 10 times. And so we're going to add 10 to the value of count. We're going to add 1 to the value of count 10 times. So that means that D is the correct answer. For option E, count is going to start at 0, k starts at 10 and goes to 0 inclusive. So 10 through 0 inclusive means that this executes 11 times and count will be 11. So the answer that we want is D, not B, like I said. And the reason B is not correct is because count equals 1. So that concludes this video over loops practice. If you still have questions, talk to me in class. Also, just try writing programs with loops, strings, and stuff like that.